In this video, I am going to discuss about the shortcut trick for determination of hybridization of a molecule. Hybridization equal to number of sigma bonds plus number of lone pair of electrons. If the total number of sigma bonds and lone pair of electrons are equal to 2, it undergoes sp hybridization. If the total number is 3, it undergoes sp2 hybridization. If the total number is 4, sp3 hybridization. Total number is 5, sp3 dehybridization. Total number is 6, sp3 d2 hybridization. 7, sp3 d3 hybridization. You can easily know the hybridization of the molecule based on the number of sigma bonds and lone pairs, because 2 means 1s orbital and 1p orbital, so total 2. So next sp2 means 1s orbital and 2p orbital, total 3. sp3 hybridization means 1s orbital and 3p orbital, total 4. sp3 dehybridization means 1s orbital, 3p orbitals and 1d orbital. sp3 d2 hybridization means 1s orbital, 3p orbitals and 2d orbital, total 6. sp3 d3 hybridization means 1s orbital, 3p orbitals and 3d orbital, so total 7. By learning this table, you can easily know the number of lone pairs, bond pairs, hybridization and shape of the molecule can easily determined. If the molecule undergoes sp hybridization with no lone pair of electrons, the geometry of the molecule is linear. If the molecule undergoes sp2 hybridization with zero lone pair of electrons, that means no lone pair of electrons, the shape of the molecule is trigonal planar. If the molecule undergoes sp2 hybridization with one lone pair, the shape of the molecule is angular or V-shape or bent structure. If the molecule undergoes sp3 hybridization without lone pair of electrons, the shape of the molecule is tetrahedral. If the molecule undergoes sp3 hybridization with one lone pair, the shape of the molecule is trigonal pyramidal and simply known as pyramidal shape. If the molecule undergoes sp3 hybridization containing two lone pairs, the shape of the molecule is angular or V-shape or a bent shape. If the molecule undergoes sp3 dehybridization without lone pairs, the shape of the molecule is trigonal bipyramidal. If the molecule undergoes sp3 dehybridization with one lone pair, the shape of the molecule is seesaw. With the two lone pairs, the shape of the molecule is T-shape. With three lone pairs, the shape of the molecule is linear. Next, similarly, if the molecule undergoes sp3d2 hybridization without lone pair of electrons or zero lone pair of electrons, the shape of the molecule is octahedral. If the molecule undergoes sp3d2 hybridization with one lone pair, square pyramidal, two lone pairs, square planar. Next, if the molecule undergoes sp3d3 hybridization without lone pair of electron, the shape of the molecule is pentagonal bipyramidal. With one lone pair, pentagonal monopyramidal or distorted octahedral. In our intermediate textbook, it is given as distorted octahedral. Here, you can know the molecule type also based on the bond pair and lone pair. Here, lone pair of electrons 0 means sp means two bond pair of electrons. So ab2 means two bond pair of electrons. So the molecule type is ab2. 3 means ab3, two bond pair and one lone pair. That means AB indicate the bond pair of electrons and E indicate the lone pair of electrons. So AB2 E means two bond pair and one lone pair. AB4 means four bond pairs, zero lone pairs. AB3 E means three bond pairs and one lone pair. AB2 E2 means two bond pair and two lone pair. Similarly, AB5 means 5 bond pair of electrons. AB4E means 4 bond pairs and 1 lone pair. AB3E2 means 3 bond pair and 2 lone pair. AB2E3 means 2 bond pair and 3 lone pair of electrons. Here AB6 means 6 bond pair of electrons. AB5E means 5 bond pairs and 1 lone pair of electron. Similarly, this AB4E2 means 4 bond pairs and 2 lone pairs. AB7 means 7 bond pair of electrons. AB6E means 6 bond pair and 1 lone pair. So molecule type also you can determine based on the bond pair and lone pair of electrons. Now we will apply this method for the calculation of hybridization. Number of lone pairs, bond pairs and shape of the molecule can be determined. For example, BF2. BF2 molecule, beryllium belongs to second group, so it contains 2 valence electrons. Here 2 fluorine atoms are present, 2 fluorines forms 2 sigma bonds with 2 lone pair of electrons. That is not 2 valence electrons. So bond pair of electrons are 2, lone pair of electrons are 0. So total equal to number of bond pair of electrons 2, lone pair equal to 0. So total 2 means sp hybridization. Sp hybridization means linear structure. Similarly, BCl3 molecule. Here boron belongs to third group element. It contains 3 valence electrons. These valence electrons are indicated by dotted structure. 3 chlorines forms 3 sigma bonds. Sigma bond is formed end to end overlapping. These sigma bonds are nothing but bond pair of electrons. So here bond pair of electrons are equal to 3. Lone pair of electrons means 0. So total equal to number of bond pair of electrons 3, lone pair of electrons 0, total 3. 3 means sp2 hybridization. sp2 hybridization with 0 lone pairs means the shape of the molecule is trigonal planar. Similarly, can determine the hybridization of any molecules. For example, SF6. Sulfur belongs to 6th group element, so it contains 6 valence electrons. 1, 2, 3, 4, 5, 6. 6 fluorines form 6 sigma bonds with 6 electrons. So 6 sigma bonds means bond pair of electrons are 6, lone pair of electrons are 0. So total equal to number of bond pair of electrons plus lone pair of electrons. This is equal to 6. 6 means sp3 D2 hybridization with 0 lone pairs means the shape of the molecule is octahedral. Octahedral. Similarly, you can determine number of lone pairs and bond pairs of xenon compounds. Xenon difluoride XeF2. Xenon belongs to inert gas element. It contains 8 valence electrons. Except helium inert gas, all the remaining gases contain 8 valence electrons indicated by dots. 1, 2, 3, 4, 5, 6, 7, 8. 2 fluorine forms 2 sigma bonds with 2 electrons. Next, it contains 3 lone pair of electrons. So number of bond pair of electrons equal to 2, lone pair of electrons equal to 3 pairs. So total equal to number of bond pair of electrons 2, lone pair 3, total 5. 5 means sp3 dehybridization with 3 lone pairs means linear. 3 lone pairs means linear. So the shape of the molecule is like this, which contains 3 lone pairs. Similarly, xenon tetrafluoride XeF4. So xenon belongs to inert gas, contain 8 valence electrons. Among 8 valence electrons, 4 fluorines form 4 sigma bonds with 4 electrons of xenon. That means bond pair of electrons are 4. Lone pair of electrons 8 minus 4, 4. 4 means 2 lone pairs. So total equal to number of bond pair of electrons 4, lone pair 2, total 6. 6 means sp3 d2 hybridization with 2 lone pairs means square planar. Square planar. The structure is like this. Two lone pairs. Next, XeF6. XeF6. Similarly, here also xenon contains 8 valence electrons. 6 fluorines form 6 sigma bonds with among 6 valence electrons. That means bond pair of electrons are equal to 6. So 8 minus 6 means 2. So number of lone pair of electrons are 1 pair. So total equal to bond pair of electron 6, lone pair of electron 1, total 7. 7 means sp3d3 hybridization with 1 lone pair means distorted octahedral or pentagonal monopyramidal. The hybridization in CO2 molecule. When oxygen molecule is present, according to the molecular orbital theory, between two oxygen particle double bond is present, one sigma bond and one pi bond. So CO2 means carbon belongs to fourth group element. It contains 4 valence electrons, 1, 2, 3, 4. One oxygen form double bond with 2 electrons. Another oxygen form double bond with 2 electrons. Here in the among the double bond, one sigma bond, one pi bond. Similarly, one sigma, one pi bond. So here bond pair of electrons means only you have to consider the sigma bonding electrons. So here bond pair of electrons are equal to only 2. Lone pair means lone pair of electrons 0. So total equal to 2. 2 means sp hybridization. Structure is linear. Similarly, SO2 molecule. Sulfur belongs to 6th group element. So it contains 6 valence electrons. 1, 2, 3, 4, 5, 6. It contains 2 oxygens. Here one lone pair. So double bond means here only one sigma bond. So bond pair of electrons are 2. Lone pair of electrons are 1. Total 3. 3 means sp2 hybridization. sp2 hybridization with one lone pair means that is angular shape. Angular or bent structure. Bent structure. So like this you can easily determine the number of lone pair of electrons, bond pair of electrons, and type of hybridization and shape of the molecule can be easily determined.